Hi, my name is Zack Scholl. I'm a tinkerer with the Gno project, and today I'm going to be talking about transitioning from Go to Gno and building a microblog in the smart contract system around Gno.land. So let's get started. First off, Gno is basically an interpreted version of Go. Gno allows Go developers like myself a pretty easy way to write smart contracts without having to learn a new language. And Gno.land is basically a platform to write those smart contracts, and I'll talk more about that later. Today, I just want to focus on getting you up and running with Gno, assuming you know some Go. I'm going to go over things that I wish I knew when I started, basically the workflow, the syntax, and then using a practical example of the microblog smart contract. Working with Gno is basically the same as working in Go. The syntax is almost identical. The workflow is slightly different. The easiest way to work in it, I think, is to use Visual Studio Code. So first, make sure you have Go installed and Visual Studio Code. And then I would recommend getting this Gno extension here. And after installing that extension, you need to install the Go funct. And then we can start with the cloning of the Gno project. So we can clone this into a directory, cd into it, and we can make install. We'll install Gno key in Gno, and then we can get Gno.land built by cding into Gno.land and do make build. Anytime you make changes to Gno.land, you'll have to rebuild if you're doing development there. Great. The next thing we'll do is to create a key. So the key will be used to authenticate transactions against the blockchain, because this is Web3. For now, there's no mainnet or testnet. Well, there is a testnet, but we're going to just use local development. So the key is just for local development purposes right now. We can generate it by typing Gno key generate, which will give us a BIP39 set of strings. And we can then add a key, Gno key add, recover, I'm just going to call this your key, and then a passphrase. And then we'll copy and paste this BIP39 mnemonic. And then we have a new key here. And we can list that key by doing Gno key list. And it's here. So for local development, we're going to use the Genesis balances to add our key into the Genesis block. So if we go into Gno, I'll change directories here, into Gno. If we go into Gno.land, Genesis balances, we can add our new key here at the end. Gno key list will list it, and we just want the address of it here. And then we'll paste it to the bottom and add some tokens for it. So this way we can do development when we spin up Gno.land without having to worry about a faucet. So Gno.land is this platform which is online now. And this is where the realms will live, and I'll talk more about that. But it's essentially the platform that you can write the smart contracts in Gno. And to me, it provides like this transition between Web 2 and Web 3, because the Gno.land basically gives you a server to interact with. Anything on the realms of Gno.land have like a render path, which will actually render Markdown, which can be processed and displayed in the Gno.land website. So you basically get a website for free, basically, using Gno.land. I'll talk more about that, but for now, let's get a local instance of Gno.land going. So I like to use a little script to start it. So we'll start Gno.land, and then we'll start Gno web, which is the web interface. So I'll just copy and paste this into a new script called start. And then run that, and it will start up. You'll see a lot of things going on as it starts up. It says running on 888, and we can go check it here, and we can see that it has indeed started up. So let's make our first transaction call, using our key. So we can make a call to the users. As we see here, there's a couple of realms, and one of them is users. And there's a couple of users, and we can add our own user to this by making a transaction call. So I like to do this thing where instead of, you can enter the password each time, or you can send the password if you do an insecure password standard in. And for now, it's just development, so I will copy my password that I made to this, so I can just add it directly. So if we run this command, if we run this command, it will use the gas and basically create a new, it'll invoke this realm, which we've invoked by this path, Gno.land r demo users, which is the path here. And when we invoke that, we're actually invoking a function. We are choosing the function register, and we're giving it arguments. So the arguments are in order using -- args. I'll go over this in a second, but for now, let's just see that I entered in something. So I should have entered in your name and your profile. So if I open up the local instance, you can see here's the user that we added, and here it is on the list. So it did indeed work. So the Gno make tx call basically allows you to call a function within a realm. So within the r demo users, that function is called register. One of the cool things about Gno.land is that the source for all these realms is available, and you can just go to them. So here, if we click source, here's the source code. And if we go to users, we can see there's going to be a function called register. And this is a publicly exported function so that we can call it with a transaction. So register has 3 arguments, inviter, name, and profile. We don't have an inviter when I made this call. It was just entering my name and profile. So I left inviter blank and then added my name and my profile. And you can see here your name and your profile. So the first argument is the address, and here it's blank since we don't have inviter. And then the second argument is your names, and third argument is your profile. And it's the same for any transaction that you make. You just list the arguments in order and then list the function using the func argument. So Gno.land exists basically as a repository of realms that you can utilize in your contract. In this case, we're using our demo users. And one thing to note is that the route our demo users is the same route as when you go into Gno.land. So Gno.land here, we have our demo users. But the path that the realm will see comes after the semicolon. So if you click on any of these, you'll see there's a semicolon and then the name. And that's actually going to be used as the render function. So if we go into the source for this, in the users, and we look for the render function, you see there's a path here. And so that path is everything after the semicolon. So yeah, here, the function that you have will be a render function, and it's everything after the semicolon. That's kind of a gotcha. So I am building this, or I built this realm called microblog, and it lives at our demo microblog. And this realm will have to add the realm, and this is what you'll do whenever you develop a realm or a package, is you have to make a transaction to add it to Gno.land. So I'll talk more about microblog in a second, but for now let's just add it and try it out. So we'll do the same thing as before. We'll make a transaction. The path will be to now Gno.land. This is a package, so it's /p demo microblog, and it lives at this folder in here. So we can just see here, if I ls that, you can see there's the code for it. We deposit some tokens to pay the gas fee, and then we'll enter in our key at the end. So if we run this, it says gas wanted, gas used, okay. So it's added a package for the microblog. What we need to also add is the realm. So to add the realm, it just happens to be the same path, but with -r instead of -p. So we can just do this command here, and this will add the realm. And it says, okay, so now if we go here, we should have the Gno-based microblog. and it's blank since we haven't added anything to it. But we can go to the source and see that it is indeed here. The source code is there, so it is working. So let's try adding a post. So as before, we're going to make a transaction call. The package path is going to be the realm that we have created, Gno.land our demo microblog. The function we're going to use is the new post function. So when we look at the source code, we see that there is a new post function that is exported, which takes text as a string. And so we'll add text, and in this case, it's markdown, so you can send any markdown you want, and it will create a new post for your key, for a user at your key. So we create this transaction, and it says added new post. And now if we go to the realm, we see that there's a new page with your name and then your hash ID. And if you click that, you can see a feed, and then here's the post that we made in Markdown and the date. And you can see here the route is given by your address. And if we didn't add our users, it wouldn't say your name here. It knows your name because we added this as a user in the realm. So this is showing that you can do realm to realm interactions, which is really cool. Yeah, it's pretty easy to get started making realms and making packages. So the difference between realms and packages is that a realm in Gno is basically code with state. So the realm in the microblog basically holds the microblog information. It holds what posts are there. It has, we can actually just look at it, the source code of it. It has this M, which is going to be the whole microblog, which is storing everything, all the pages and the feeds. A package in Gno does not usually have state. It can have data, but it's also usually code that's used by other realms. You can import realms just like you can import packages. Package is basically like a traditional Go package, but a realm, the special thing about a realm is that it also has a render path. So it has this render function which you interact with through the Gno.land server. So everything on this page is basically composed through these render functions. So like users is rendering list of users, and if we go to the microblog, it'll render the microblog. So it's like a Web 2 server built into Web 3, which is pretty cool. And if we look at the Go code a little more, so this is now the package of the microblog, we'll see that there's some differences. It's exactly Go code, except for a few things. So if you look at the imports, you'll see that there's a std package, and then there's these Gno.land URLs, which are leading to different packages. And these are slightly different than they are in Go. I mean, standard is not in Go, but there are reasons for these, and I'm going to go over those now. So standard is a special import. The standard package is a Gno specific package that lets you access the address. So in microblog, this is used when you create a new post. You're making a new post with just a string, but it knows who you are because it gets your address from the call. Remember when we made this call, we enter our key in as part of the call. And so it sends our key address. And then in this package, we're able to get that address by using standard.getOriginalCaller. So now we have what's called a standard.address, and you can turn that into a string with .string. But this way, you can easily get the caller information when a call is made to a package or a realm. So standard is a really useful but a very Gno specific package. So another thing that we can see if we look at the code here is this AVL. So AVL is a package that stores an AVL tree, which is a self-balancing binary search tree. So an important thing to think about when using Gno is that Gno is completely deterministic. And the reason is that it needs accountability so that only one path exists between states for validators to reach consensus in the blockchain. So the AVL tree can be used because it's a deterministic map. Well, it gives map functionality, whereas Go's map ordering is indeterminate. So these are some issues that are tracking these things. So These things could change in the future, but for now, I would not use a Go map. I would use the AVL tree instead. And you can use it a lot like the sync map in Go. So you can do sets, you can do gets, and you sets, it's an interface, so you have to cast it back when you get it. And you can also use it, you can do iterates with it as well, and that's shown here. So like in microblog, it's basically, it sets the pages as an AVL tree, and that's a map of all the pages from the author, indexed by the author. And so here it's initializing it, and then here it's iterating through them, and it's returning them whenever you get them. So all the data is stored in this map, but it's not stored in a Go map, it's stored in the AVL tree, which is provided by Gno.lang. Okay, another thing that's important to remember is as of right now, Gno doesn't support reflection, so there's another issue tracking this. So some of the things in the Go standard library don't work right now in Gno. So there's workarounds for them for the most part until they're ported over. So for example, format library uses reflection in Go. So in Gno, it was ported over, but in a micro implementation called uformat. So you should use uformat whenever you want to use the format library. So if you're doing format.sprintf, instead you'll do uformat.sprintf. And so for example, in the microblog, this is done many times, but like for instance, printing out the markdown when it's rendered, it prints out uformat.sprintf and then the title instead of format. If you use format, it may run into problems. Another example of the lack of reflection problem is that sometimes, like if you use sort.slice doesn't exist because it uses reflection. But you can get around this. You don't need a special package. You can just use the lens swap less methods. That's also in the microblog code. So I use these methods to generate a sort, and then I can sort by the last posted pages in the microblog. And yeah, the other major difference in Go and Gno is in the imports. So the standard library is pretty much the same. Many of the packages are the same, except for the things I just mentioned that use reflection. It's currently unable to import third-party code other than realms and packages. So there are many packages and many realms. So here's a list of all the packages. And there's many packages that you can use for Web3 things. And then there's many packages or many realms that you can use. And you can use realms like I use the user's realm for microblog. There's also like NFT realms and boards realms, bank test realms. And you can also use any packages. So one of the packages I used in the microblog is AVL trees, and the U format is here. And you can add more packages and more realms, but they all right now live in the examples Gno.land P demo. So when we call them here Gno.land P demo, it's actually calling them from the repository in the Gno code. So that's all in the Gno code right now. So that's important to remember. So if you want to import something, it's not a third-party program here. It's actually a local code that's transpiled when you compile the Gno code. Yeah, so that's a quick startup for getting ready with Gno. So if you know Go, you pretty much already know Gno. That's part of the power of it. I think this talk is just a short talk just to get you kind of jump started if you want to get into Gno and you know some Gno. This will get you quickly in line. If you want to know more information, there's a bunch of great resources at the Awesome Gno, more startup hints, more projects, but do look at the examples in the realms. These are really good examples on getting started, and you can see how the Gno code is used and how sometimes you can get around the reflection and how to use the standard library. So with that, thanks for listening.